I have here a question that requires us to find some exact values of some trig ratios. In most cases, when a question requires you to calculate the exact values, the use of a calculator will result in approximate values. So I'm going to show you how we can make use of the Cossack diagram to find these exact values. The question says that the obtuse angle B is such that tan B is equal to minus 5/12. Find the exact values of sine B. So if I take you through the quadrant diagram, which I'm going to show you contains the angles from 0 to 90 degrees, and this one is going to be 180 degrees, 270, and when we complete the revolution, this is going to be equal to 360 degrees. You know by now that this quadrant here is going to be the only quadrant in which the cosine ratio is positive. Here all of them are positive, and here the sine is the only positive ratio, and finally in the third quadrant only the tangent is positive. Now in our current question, we know that the angle B is obtuse. So if I'm going to rotate the angle B starting in an anti-clockwise sense, it is going to lie in this quadrant here. It's going to be in the second quadrant, because an obtuse angle lies between 90 degrees and 180 degrees. So if I draw it and make sure that I incline it to something like that, then this angle here is an obtuse angle, and that is going to be angle B. And you can see that this is correct because tan B has to be negative minus 5 divided by 12, and that's true. Tan theta or tan B is negative in the second quadrant. If I drop a perpendicular to this negative x-axis, I will be able to make use of this right angle triangle to find the required trig ratios. And I know that the tan of B is going to be, so let's have a look here what tan of B is equal to. So tan B is going to be the opposite divided by the adjacent side. And in our current problem, we've got minus 5 divided by 12. So the minus 5 is going to be the opposite, well, 5 is going to be the opposite side. So I'm going to make it a 5. It cannot be negative because it's above the x-axis. So this one here has got to be the positive 5, and the adjacent side, because it's on the left hand side of 0, so this is going to be negative 12. Okay, now we can use Pythagoras' theorem to find the length of the hypotenuse, and I'm pretty sure you'll be able to do that. So 12 squared plus 5 squared is going to be 169, and the square root of 169 is going to be 13, so the hypotenuse is going to be 13 units. Now that we have that diagram, I should be able then to go and answer or find the answers for the required ratios. So the sine of B, as you can see in this diagram here, if I wanted to work out tan B, I could simply say that it's the opposite side, which is 5 divided by negative 12, and that is consistent with my question that I was given. So sine B is going to be equal to, we know that sine using SOHCAHTOA is going to be equal to the opposite side, which is 5, divided by the hypotenuse, which is equal to 13. And you can see that sine is positive in this quadrant, so that is how you would find sine B. So moving on to the second one, let me use a different colored pen. We're looking for cos B. Cos B, using the same argument, is going to be the adjacent side, which is minus 12, divided by the hypotenuse, which is equal to 13. And finally, we are looking to find item C, and C is going to be slightly different because of the 90 plus B, so we will make use of some reduction formulae to reduce it just to the cosine of B. Now we know that this can be written as cos of 90 minus B. Let me use a square bracket here to show that I've got some brackets inside, and this here is going to be the same as the sine. Maybe let me write it here. We know that the sine of theta is going to be equal to the cosine of the complementary angle, which is 90 minus theta. So the sine of theta is going to be equal to the complementary the cosine of the complementary angle. So using the same argument, I now have the cosine of 90 minus b. So this is just going to be equal to, therefore, using this argument here, we will know that cos of 90 minus b is going to just equal the the sine of the complementary angle, which is equal to minus b. It is complementary, you can see. If I say 90 minus b plus minus b, that is going to give us 90 degrees. So this here, from the knowledge of the graph of sine theta, we know it's going to be equal to the negative sine of that positive angle. But in our current question, I've already worked out what sine b is equal to, and so let me make a little bit of space here. The sine of b is equal to 5 over 13, so this is just going to be equal to minus 5 over 13 as your final answer. Okay, I hope you have an understanding of how we can make use of the cos diagram to find these exact values. I have another question for you that I'm going to give you, and I'm going to ask you to pause the video and attempt this question on your own, and once you're happy with your solution, you can come back and compare yours against mine and see if we agree. Okay, so this is the question that you will attempt. You can pause the video now and attempt it. Okay, welcome back. I hope that you had some success in this question. Let's get to it. It says, given that sine theta is equal to minus p and that tan theta is less than 0, where p is a positive constant, find a cos theta, b cosec theta, and c tan 180 plus theta. Now, before we attempt these ones here, we will need to identify in which quadrant sine theta is going to lie. And so we're going to do that by making use of our cos diagram. So if I draw the cos diagram here, and again I'm going to go ahead and label the quadrants. So cos is spelled in this direction here. Now we know that sine theta has got to be negative, so sine theta cannot lie in these two quadrants here. Here all the trig ratios are positive, and here sine is going to be positive. Okay, so I'm going to eliminate those two straight away. The next one says that and that tan theta has to be less than 0. So if a number is less than 0 in the real number space, that number is going to be negative. So we are saying tan theta must be negative and sine theta must also be negative. So this here, tan theta is positive, so this quadrant there has to be disqualified as well. So that leaves us with only the fourth quadrant as the location of theta. So if I draw a new diagram here and incline it at this angle here, then I can use this new triangle, this right angle triangle as before, to calculate the trig ratios that relate to theta. So if I drop a perpendicular there, I know that sine theta is going to be equal to negative p over 1. Now we also know that sine theta is the opposite side divided by the hypotenuse. So the hypotenuse has got to be 1. So the hypotenuse will be equal to 1. The opposite side, and you can see that this is below the x's, so this will be equal to minus p. Using Pythagoras' theorem again, we should be able to find this adjacent side here. If we mark this as my angle of interest, the adjacent side is going to be equal to plus or minus the square root of 1 squared minus p squared. But I'm going to take the positive value because I know that this is on the right hand side of the x-axis. So then that is going to be the square root, the positive square root of 1 minus p squared. So now I can be in a position to answer the required questions. So if I'm looking for cos theta, it is going to be the adjacent side, which is the square root of 1 minus p squared divided by the hypotenuse, which is equal to 1. So I could just say that cos theta is the square root of 1 minus p squared. Okay, now let's have a look at the second one, Cossack of B. You will need to make use of an identity here. Cossack of theta is going to be the same as 1 divided by sine theta. But we already know that sine theta is equal to negative p, so this is going to be equal to minus 1 over p. So that's what cosine theta is equal to. Now the final one, we are looking for the tangent of 180 plus theta. Now by the periodic property of the graph of y is equal to tan theta, we know that this graph is going to repeat itself after every 180 degrees. So I'm plussing theta to 180 degrees, so that there is just going to be the same as tan theta. Okay, and if I go onto my graph, and if this was theta, then tan theta is going to be the opposite side over the adjacent side. So the opposite side is minus p, and the adjacent side is equal to the square root of 1 minus p squared. It'll be interesting to note that we could also make use of this identity here. We know that tan theta is just the same as sine theta divided by the cosine of theta. And we know that sine theta is equal to minus p, so I'll write minus p. And we've just found that cos theta is the square root of 1 minus p squared. And that checks out as before. Okay, that brings us to the end of this tutorial. I hope that you found it to be useful. Thank you for watching.